Welcome to the 2025 user group meeting. I'm Becky, and in this session, I'm going to show you how you can create some 2D wall art just like this. Now, you may well have seen this style of artwork in contemporary spaces like hotel lobbies or offices, and they look super impressive. And we're going to show you how we can essentially take a 3D model and turn it into a 2D slot together part that then creates a 3D piece of artwork that you can put on your wall. So the installation itself consists of a backboard and then lots of parts that slot into that backboard. So it's literally one backboard and then a million parts that slot into that. So how do we do this? So first up, we're going to look at creating our initial 3D model in Aspire. And once we have our 3D part, we're then going to look at the geometry required to create the profiles and the slots. And the really important part here is ensuring that everything lines up correctly. So in this session, we're going to cover lots of tools and lots of functionality, from looking at how we can manage our sheets, how we can manage our layers. We'll be looking at lots of different drawing tools, nesting, array copy, and then ultimately looking at the toolpaths. Right then, so I think it's time we jump straight in. So we'll start by creating a new file. So we're going to work with a single-sided session, and I'm going to set up my job so that it's just a little bit bigger than the overall artwork that I want to create once it's assembled. So I'm looking at a wall that's around 5 foot wide. So I'm going to go with a width of 60 inches, a height of 48, and then the material that I'm using is birch plywood, and the thickness that I've got is 0.36. So we're going to put 0.36 in there. We're going to have our Z0 position on the material surface, XY is going to be in the lower left-hand corner, and we're going to be working with a very high modelling resolution. And the reason for that is we are creating a model initially, and we want to just maximise the amount of pixels that we've got in our workspace. So once we're happy with that, we'll go ahead and press OK. Now the first thing that we're going to do is we're going to import a bitmap. So I actually drew up this sketch just on a piece of paper, and then I just took a photo of it, emailed it to myself, and I've just brought it in like you can see here. So this is the shape that I want to go for, and the idea here is we're going to look at sizing this up, and I'm going to look at tracing that shape using the polyline tool. Now before we carry on, I'm actually just going to draw in a rectangle that's this size of our job, and I'm going to use that in order for me to crop my bitmap to. So we're going to take that, we're just going to size that up like so, maybe a little bit more, and then we'll just nudge it over. Looks pretty good, so we'll take that vector and then we'll just crop that bitmap. So we're just working with the constraints of our job, and I'll just delete that vector there. Right then, so we just switch on the bitmap visibility in the 3D view. I'm going to look at drawing this blob shape. So we're going to use the polyline tool. Now this is just one of the favourite tools that I like to use, and I like to use it in straight mode for creating organic shapes, because I find that when I click at each apex, I'm able to then go in with node editing afterwards to really get the curvature. And because I've pinpointed all of those, those curves, I'm able to easily just transform those into smooth points, and generally it should follow the curvature, which you can see it's done pretty well here. So all I need to do now is just go in and just tweak those handles, pull on the handles, move those nodes around until it looks like the vector, or rather the actual drawing that I've got from the photo. So we're just going to move that over here, and then we'll pull that over there. Maybe stretch that out also. Move that down, and you can see all I'm doing is I'm just moving, tweaking all of those handles, those node points, until I have a shape that looks pretty similar to the actual bitmap. So happy with that, looks pretty spot on there. Okay, so that's our general outline for our part. And what we're going to do now is we're going to look at using this with the 2-rail sweep tool. So what I need to do is I need to actually separate this vector into 2 different rails, and that will enable me to then apply some cross sections that I'll draw in a moment, and we can sweep them along those rails. So we're going to go back into Node Edit here, and I'm actually just going to cut the vector at 2 points, so one on the left side and then one on the right side. I'm trying to again hit that apex, so we'll just put a C there to cut that. So now I've got 2 separate parts. Right click to come out there, and now we're ready to draw in our profiles that we're going to sweep to create our blob model. So to help me do that, I'm just going to roughly draw in a rectangle. That's pretty much the height of the job. It doesn't really matter because it's going to scale inside of the 2 rails that I'm going to use anyway. Now your profiles, when using the 2-rail sweep, they need to be open vectors. So we're going to go into node mode, and we're going to delete this span by pressing D here. And then it's just a case now of me just creating some kind of organic roundy blobby shape. So we're just going to insert some points in here. So we'll just delete that. Oh, let's just undo that. Okay, undo. I actually want to delete the node, not the span. And then I'm just going to select these, press S to put them into smooth mode. Pull those handles down so that they're parallel in terms of the x-axis there. And then we're just going to really wiggle these shapes around. Okay, so something like that looks okay. And there's our first cross section. Okay, happy with that, so I'll just nudge that over. And then I'm just going to create a copy of this one by pressing Control and Alt. Again, let's go back into Node Edit mode, and then this time we could look at just tweaking that shape. Okay, so again, we're just playing with those handles and really just altering the profile, so we've got more of a wiggly shape. Happy with that. We'll take that one. Again, Control Alt to pull out another shape here. Node Edit, let's just pull that back. Let's just pull this handle out like so. And then we'll make this one out like that over here. Okay, so something like that. Maybe I was going to add a bit more curvature there. It looks a little bit straight, so we'll pull that down, and we'll also pull this handle up just to give it a nice curve there. And then we'll take this profile, Control Alt, pull that out, Node Edit, and then again we'll just edit this final shape. So perhaps we'll delete that. Could nudge that in, pull that out, and then bring this in, pull that up, pull that out. So we have a shape that looks like that. Okay, so I'm happy with those cross sections. So now we're ready to actually create the model. So I'm going to tile our windows so we can see both the 2D and the 3D view. So we're going to take the top vector, shift and select the bottom vector. I'm going to go into this function here, which enables us to create a 2-rail sweep. So first off, we select our 2 rails. So I've selected those, and now I tell the software, yep, I want you to use these as my selection. They've now been transformed into drive rails. We can see the direction of those drive rails. They are both traveling from this node here, going from left to right. And that's indicated by those arrows. So they're going in the same way, which means that when we apply a profile, they're going to be flowing in the same direction. And that's the case of us just adding in those cross sections. So you can add one, or you can add multiples if you wanted to. So here I'm going to take this one, I'm going to apply it over here, like so, and that's applied that all across the board. I'm going to take this one, and I'm actually going to apply that here, and we can see we've got a yellow indicator here, and we've got a yellow indicator there. We also have a number, okay? So that's telling me this vector has 4 spans, this has 3. So if you wanted to be a bit more seamless in terms of how we join them, what we could do is we could add in more spans so that each of those vectors have the same number of spans. So for example, we could come over here and we could insert another one, and then we could just reselect those rails, and you'll see now we don't actually have those numbers. And then we could take this vector here, okay, and I could apply that to the center. You can see we've got a green node there, and we've got the green on that cross section over here as well. Just straightening that up just so that those profiles are straight in terms of the top and bottom alignment where the rails are going to be traveling to. And then actually over here, I want to go back to the yellow one. So I'm going to take that, I'm going to put that over here like so. I'm going to take this last one over here and apply that to the end there. And again, you can see we've got a number 3 there. So I'm just going to go into node edit. I'm just going to insert another node there. And then what we're going to do is just come out there, just reselect those rails, and you can see everything all works out fine. And what we should see now is each of these spans are going to seamlessly blend into the next one. And so what we could do is go ahead, press apply, and we can see the result of that. Let's just turn off the bitmap visibility here, and if we just maximize our 3D view, we can take a look at our 3D parts. That's looking pretty nice. I'm happy with that, so we're just going to call this one blob, and then we'll press apply, and then we'll just close out. Okay, so put that into the top view here. And then what we're going to do is I'm just going to take that, I'm going to go into the sculpting tools, and I'm just going to be quite vigorous here. And we're going to just smooth off those creases. So I'm just going to up that strength. I'm just softening all of this here like so. So just softening that out just to take the edge off. It's not vital that we do this, but I feel like we'll get more of a sort of natural curvature when we actually come to slice this to create our 2D parts. Okay, so I'm happy with that. So this is our part here. Now we can take a look at the height of that, and we can see that's currently at 5. I'm going to whack this right up to around 12. So we've got some really, you know, accentuated undulations there. We've got lots of real nice curvature, and that's looking pretty nice there. Okay then, so now that we've got our 3D model, what we're going to do is we're going to look at a way that we can kind of get a visualization of how this would look on the wall with all of those parts sliced up. So we're going to look at using the array copy tool, where we're going to create a vector that represents the thickness of our material. And we're going to array that along our board at the spacing that we want our parts to slot into that backboard. And then we're going to use the clear area outside of selected vector functionality on the model to get rid of everything that we don't need. And that's going to really give us a real nice indication of what our part will look like before we even go ahead and create all of the vectors that we need. So we're going to first start by drawing out a vector. Now I'm going to draw out the vector that's going to be 36.36 wide, so that's our material thickness. I'm going to go 48 high, so in here I'm just going to change that to 0.36, and we'll OK that. So we've got a rectangle here that is 0.36, the exact same thickness as my material, and then it's just the full height of our part. Now we're going to array that across our board. Now I'm just going to nudge this over just so at least we're sort of on the initial part of our model. So we're going to go into the array copy tool. Okay, so here we're going to set our rows to 1 because we're not going up, we're only going across. And then in terms of our columns, we're just going to go for 82. And I've done this before, I know there's a lot of parts. And then we're going to have a gap of 0.36. So every time there is a rectangle, we're going to have a gap of the same material thickness, and then we're going to have another rectangle. And then we'll just go ahead and press copy, and then it's just going to do that for us. So it's done that there, like so. And you can see all of those rectangle vectors there. Now the next thing we need to do is we need to take those vectors and then we need to crop it against our model. So we're going to select all of those vectors, and then we're going to just zoom in here. We're going to shift and select our model. And then what we're going to do is we're going to use this handy tool over here to clear area of selected component outside of those selected vectors. And then when we do that, it's just going to remove everything that is not inside one of those rectangles. And so when we undraw the visibility of our vectors, we get a good idea of what our part could look like. And this pretty much is an accurate representation of what our part would look like. And you can kind of see what our side profiles would look like, somewhat at least, because obviously you're not going to have the actual curvature. We're going to have a straight top for each one of our slices because we are cutting it in 2D. But generally, this is the shape that we're going to ultimately get when we come to assemble everything right at the end. So let's just put that into the top view. So at this stage, what we need to do, we now have our 3D part, we have all of the slices, we know what it looks like. And we need to now convert this into 2D. So we need to now focus on creating a backboard. We need to focus now on creating all of the different profiles and then figure out how they're all going to join up together onto the backboard. So what we're going to do now is we're going to look at joining our two rails back together. So I'm just going to undraw the visibility of our 3D model for now. And then what I'm going to do is I'm actually just going to delete all but two of these vectors, and you'll see why in a moment. And we're just going to take these two vectors and we're going to join them up. So we're just going to join them at a common point, and we can see now that they're joined. I don't see any black rectangles. I can see it's now a closed vector. And then what I'm going to do is I'm actually going to look at drawing a line, a center line between the top and the bottom of the rectangle. And the reason for that is this will give me a good midway point of where we've split up that component, and I can use this vector in order for me to line up my profiles when I come to look at other tools that will help me do that. So we'll just space to accept that, and then we'll go up to the top here and we'll do the same over here. So snap to the top there, and then we're just going to come over here and we're just going to snap to the bottom there. Okay, now I'm actually going to look at deleting those rectangles as I do not need those anymore, like so. And then whilst we're here, I'm actually just going to measure the distance between each one of these. So we're going to measure between 2 points. So let's just go jump into the 2D view to enable me to do that. So we'll click here, click there, and I can see that that's at 0.72. So I know that I need to create my spacing at 0.72 inches. So we'll close out. I'm just going to delete this one. I only needed that as reference to measure that. And then we're going to take this vector, and then what we're going to do is we're going to go back into that array copy tool. This time we're going to set that distance to 0.72. We're going to copy that, and you can see that's done that there for us. And we can see according to where our grayscale model is, that's going directly through the center of each one of those 3D parts. So I'm happy about that. So with those vectors, we're going to shift and select this vector here. We're actually going to look at cropping it back. So we're going to use this option here to trim those vectors to the outer or to the last vector in our selection, which was the blob shape that we've got. So we're going to clear everything outside that, clear it, and we can see that there. So these are the vectors that we need for our part. Now that we have the foundations of our wall art, what we're going to do next is we're going to look at using the geometry that we have so far in order for us to create our slots and our profiles. So right now we can see that we've got a vector here that represents our backboard, okay? So this is going to be for the backboard. We're going to profile that out. Every one of these lines is going to represent the position of our slot. It's also going to represent the back side of each one of our profiles, which will make more sense as we go on. And so the important thing here is that we create the profiles and those slots here, and then we can look at sort of further organising our part by sheets to ensure that we don't have any crossovers, we don't make any mistakes. But for now, what we're going to do is we're just going to take a moment just to organise our part into layers, okay? So we're just going to go to our layer management. I'm actually going to rename layer 1, and we're just going to call this one profile positions, like so. And we're going to add in a new layer, and we're going to call this one backboard and slots. And then we're going to add in a new layer, and we're going to call this one profiles, okay? So we're just going to take this, let's just change some of these colours. So I'll go for like a greeny colour for this one here, and we'll go for a sort of purpley colour over here for our profiles. So we're going to take this and we're going to move it, or let's see, we're going to copy it. Let's move it to a layer. We're going to move it to the backboard and slots. And then with these are our profile positions. So we're just going to kind of just leave those there. But what I might do is just change the colour of this. So it's kind of light grey. So it's not too, it's not too bold that it's going to hide any other colours. So we're going to first start by looking at creating our slots for our backboard. So let's make sure that that is the active layer. Now, the way that we're going to do this is we're first going to look at drawing a rectangle, okay? So mostly I want our slots to be around sort of 2 inches wide. Now, I know when we get to the edges over here, they're actually going to be quite small, because obviously where the curvature of the actual backboard is, we're probably not going to get a 2-inch slot in there. It'll cut through. So we need to just we can tweak that as we go. So I'm going to go around 2-inch slots. They're going to be the same as the material thickness. And the idea is on the backboard, we're going to cut all the way through, okay? And we're going to then create one, and we're going to do an array, and we're going to jig some of these around. Now, from this point on, there's going to be a lot of processes throughout this session where I'm going to be repeating myself. So we'll show a few as an example, and then what we'll do is we'll just open a file that we've created earlier. It's kind of like at a checkpoint, so that we're just not being repetitive. No one wants to see me make a million rectangles, so we'll jump ahead in various points in this demonstration. So we're going to start by drawing out our rectangle. So we're going to start with a width of 0.36, but we want our height to be 2 inches, okay? So we want a 2-inch tool, okay? So I'm looking at the wrong value there. So we're going to go here, I'm actually going to change that to 0.36 by 2, and we can see that there. And then the most crucial thing is I want to make sure that I line that up to the center of the first line, okay? So it has to be aligned to the center of your line. Otherwise, this is going to be all out of whack. Okay, so with that, we're going to take that, and then our first job is to first go into the array copy tool. And then here, we're just going to go back to 0.36, because that's going to be the distance between each piece. So we're going to have a slot, we're going to have a part, then we're going to have a gap that's the same thickness as our slot, and then we're going to have a slot, and then a gap, and so on. Okay, so we're going to go and copy that, and we can see what it's done there. And so what we're going to do here now is we're just going to sort of jig these around, okay? So first up, I can see this one is going to be way too big. So we're actually just going to look at decreasing the height of this. So we're going to make the height of that, we're going to make that 1. Okay, so we'll just put 1 in there. And I'm just going to line this up sort of to the centre there, like so. That looks okay. And then for everything else, what we're going to do is we're going to look at moving them around the board, so that ultimately we want to have at least a minimum of 2 slots per profile to slot into our backboard, unless it's a really small piece, and we can suffice with just 1, just like the first one that we've got here. So I'm going to just take pretty much all of these, for example, okay, and we're just going to nudge them down like so, okay, and then I'm going to take a copy of that, Control and Alt, and we're just going to nudge them up slightly, okay. And what I might want to do is, where we've got more height here, we could just take all of those that are in here, and you can see that when I'm dragging from sort of the left downwards into a right position, everything that's totally inside of my selection is selected, which is really handy when you've got lots of vectors around. So I'm just going to move that, and then here, because we've got quite a big stretch here, we've got real long length here, I'm actually going to look at perhaps adding 3 pieces to the bottom area over here. So something like this, we can take that and then press Control and Alt, and then we'll just kind of keep moving things around, ensuring that we've got enough space, that they're not too like for example over here, you can see they're at the bottom. We'll move them up into the middle, but I'm not going to do that now. What we'll do now is we'll look at a file that I've made earlier that's got everything laid out. So we'll just go ahead and open that up now. Okay, so you can see that we've got all of those slots laid out. If we just zoom in, you can see here, I've actually gone with a vector here, it's quite small. You can see the height of that is at 1 inch. Here we've got one that is at 2. Pretty much all of these are at 2, and then over here we've got 1.5, and then we've got another one. But you can see I've laid these out so that we've got lots of slots, so we're trying to cover all areas that, where it's wider, we've got more slots in there. So we're just kind of making sure that structurally it should all hold together because we're introducing those extra slots. But that's pretty much it. So we've got our slot laid out. So now we can start to think about the profiles. So we're going to go into our layers bar, and we're going to make the profiles layer the active layer. We're just going to switch off our backboard and slots for the time being. We don't need to see those. Make sure profiles is the active layer. Then we're going to switch on our 3D model. So the idea here is what we're going to do is we're going to use a tool, which is this one over here. And this enables us to create a cross-section vector based on your 3D model. And so the reason why, this is another reason why we've got those straight center line vectors that we put in, so that I can actually snap from the top to the bottom to ensure that I get an accurate, straight profile reading of our 3D model. Now, when you're using this tool, you don't actually have to have the 3D model switched on, or at least have it visible in your 3D view, which makes it really easy for us to kind of see what's going on here. So I'll start by doing a few so you can see what it looks like. So for example, we're going to click, you can see I'm snapping to that point there, drag that down, and you can see that crosshair that's telling me that we're snapping here, and we can see that profile shape. So let's just remind ourselves, if we just go in here into our 3D part, you can see that's pretty much the shape that we're getting here. Okay, so you can see it's pretty good, accurate representation of what we've got there. So let's just draw the visibility of that model off again, and then we'll continue with some more. So again, super easy to do. Create cross-section vector, click, make sure you snap in, snap to the bottom. So those crosshairs are important to see here. And again, because we've got those lines drawn in, we know that we're going straight down. We've got a nice straight line there, and everything should sort of line up perfectly. And then the idea is we're actually going to look at using these shortly to actually join them to create our profile sides, okay? So at this stage, we'll carry on and we'll do this probably another 5 minutes or so, probably not even that, probably just 3 minutes. We'll create all of the other profiles here, but we're just going to jump ahead. So I'm going to look at opening a file that we've made earlier that's got all of those profiles in. So let's go ahead and do that now. Okay, so here we are, and we can see all of those profiles. And you can actually see that shape. It's really cool, and you can see all of that curvature there. Right then, so we've got the crux of our profiles, our slots. So now what we need to do, we need to look at organising our file even further. And we're going to look at organising this part now by sheets, just to ensure that, everything is in its place. So we're going to go to our sheet management up here, okay? So we're just going to rename this sheet to original design, okay? And then what we're going to do is we're going to add in a new sheet, okay? And we're just going to rename this, and we're going to call this one profiles, like so. And then what we're going to do is we're actually going to edit this sheet. So go to edit, and we're going to now translate that into the size of the sheet that we're actually working with, which is a full sheet. So 96 by 48 in here. And then we'll go ahead and press OK. And then whilst we've got our sheets list open, we're actually just going to duplicate this sheet, and then we're going to rename this sheet, and we're going to call this one backboard. Okay, right then, so we've got a backboard, we've got our original design, and we've got our profiles. So what we're going to do, we're going to now start to sort of move and copy our vectors over to those different sheets. Okay, so if we go back to our original design, and then what we're going to do is we're going to take all of these vectors here, like so, and we're going to right click and we're going to say copy to sheet, and we're going to say copy to profiles. Okay, and then what we're going to do is we're just going to switch off our profiles layer for now, and then we're going to take this sheet here and we're going to right click and say copy to sheet. We're going to go to the backboard. Okay, so let's just switch on the visibility of our profiles. We're actually going to work from our profiles sheet now. So you can see where we've got that sheet. Now here I don't actually need to see the backboard and slots just for now. We'll make the profile layer the active layer. And what we're going to do is we're actually going to look at joining each one of these profiles to the straight line vectors that we've used to represent the midpoint of our slot. So the easiest way to do this, if we go to our design tab, I'm just going to select both of those. Now it's good, a little point here. Whenever you see this little black square, that's telling you that you've got open vectors. Okay, so we've got two vectors selected, but it is open. So that's your indicator. So we're just going to use this tool here to join them, and you'll see now I've joined them, that little black square's disappeared. Okay, what we're going to do as well is we're just going to actually move that to our profiles layer, and what I should do is make our profiles layer the active layer as well, like so. And then we're going to take that, we're going to join them, take this, we're going to join them, like so, keep joining them, and we're just going to do this for all of them until we have all of those profiles joined. So again, we're just going to jump ahead. Probably spent another few more minutes doing that. So we're just going to jump over to a file where we've got all of those parts joined. Okay, so we've got all of our profiles now joined to those back straights. So just to double check, it's always good practice when you are closing vectors, if you right click and go to select vectors and then select all open, just to ensure that we can see that there are no other vectors that are open in our design, and if there are, it would actually flag it up here that you do have some. So we don't have any, which is perfect. And so now that they're all joined, our next step in our project is to actually create the tabs for our profiles. Okay, so we're again going to look at adding in some more layers in order for us to keep our parts super organized. I did say earlier, like, you know, this can get quite messy, so we're just going to add in a new layer. So here we're going to go and create a new layer, and we're going to call this one profiles with tabs. Let's just make that like a sort of a like grey colour, and then we're going to add in a new layer, and we're going to call this one slots for welding. Okay, and then we'll just give that just a colour like so. And then what we're going to do is we're going to look at copying some of these vectors to those particular layers. So we're going to take all of our profiles so far, like so, and we're going to say copy to layer, and we're going to copy that to profiles with tabs, and then we'll just turn the profiles layer off. Then we're going to turn on our backboard. Let's turn these off as well. Turn on the backboard and slots, and we're just going to select everything, all of the actual slots here, so you can see them, and we're going to right click and we're going to copy those to the layer, and we're going to copy them to slots for welding, and then we'll just switch off the visibility of that one, switch on the profiles with tabs, switch on the slots for welding, and we're going to make the profiles with tabs the active layer. Right then, so what we're about to do now is first we need to look at moving all of our tabs, and we just need to shift them over to the left by half of the material thickness, okay? Because we've aligned all of these tabs along the center line of those profile lines. So we just need to move them over. And the reason for that is because we want to make sure that our tab for our profiles is the full thickness of our material thickness, so that when we slot it into the backboard, it's going to be flush to the back, because our backboard is going to be cut all the way through. So what I mean is it's going to look something like this. So this is a test part that I cut earlier. Okay, so this is a profile. Okay, so there's our profile. Here is your straight, here is your tab. So we need that tab to have the full material thickness here. And then it's this tab that is then going to slot into our backboard here, which we're cutting all the way through. So this full tab is going to slot in there, and it's going to be flush with the back of our backboard. And so we will get a nice flush fit. So what we need to do first is we need to select all of our tabs to begin with, okay? So the easiest way to do that is to just go ahead and just select all of those slots by double clicking on that page on the layer, and that will select everything in that layer. Okay, then what we need to do is we need to shift them all. We need to move them all over by half of the material thickness. So our material thickness is 0.36. We're going to move them over by 0.18, okay? So we're going to use this tool over here, the Move Selected tool. We're going to make sure that we're moving it relative, okay? Relative to where their current positions are. And then we're going to go negative 0.18. Why I'm doing a negative is we're going to go negative in the x-axis. If it was positive, we'd be going right in the x-axis. So we'll go ahead and press apply, and we can see everything has now shifted over by 0.18. Okay, so happy with that, so we'll just close out. So that's the first part of it. What we need to do now is we want to make sure that when we come to join in these two together, that we have a nice overlap. And so I'm going to look at using the welding tool. And it's going to make my life a lot easier if I just have a very slight overlap where our tab overlaps into our profile. So we've got a clear distinction of the two shapes that the software can then eliminate those overlapping areas. And so what I want to do is I want to just increase the width of each of these slots just by a minute amount, okay? And it's only the width that I want to change. I want to change it going from the left out to the right. So we're going to look at doing that now. Now I know that some of these are actually different sizes. So if we go into the Set Selected Object Size tool, okay, we're going to use this option here to scale items individually, okay? And that means that we're going to scale them on an individual basis rather than as a sort of bulk group and it scale out proportionally based on the bounds. So we're going to scale items individually, and I can see straight away that underneath the width and the height, we've got a various percentage. That's the software's way of telling me, hold on, some of these actually aren't the same. So you might want to think about that. And we know that because we know that this vector here, if I shift and deselect it, we know that that's a smaller tab than what we've assigned everything else. I also know that these are also of a smaller height. So I'm just going to shift to deselect those also. And I'll deselect this last one, and we can see now it says 100%. So I know that all of those individual items are of the exact same height and width as each other. Right then, so we're going to make sure that we set our anchor point from the lower left-hand corner. This ensures that when we're scaling that, it's going to scale from the corner going to the right. We do not want it in the center because that's going to scale out that way. Everything's going to go totally out of whack if we do that. So I want to make sure it's from the left. We want to make sure link XY is not checked. We do not want to scale this in proportion. And then what we're going to do is we're just going to increase the width here, and we're just going to make that a very small 0.37. And if I zoom in, what we should do is we should see the right hand side just eke out just a little bit. So 37 like so, and then we'll press apply, and you'll see that everything just moved out from the right there. Okay, so whilst I'm in this, we're going to take this one, and again we're just going to say 37, press apply, and you can see that we've got a nice overlap here like so. And then if we just move over to these vectors over here, we're just going to take all of these. I know that these are all the same height, see 1.5, and again 37, apply that, and then we'll take this one, do the last one, 37, apply that there. Okay, so we've got all of our tabs in the correct position, and everything's sort of sized up correctly. So our next stage is to now actually weld them together, okay? So what we're going to do is we're actually going to weld them by using the welding tool. So I'm just going to select both of them like so, and I'm just going to use this tool here to weld. And we're just going to take that and weld. And we're going to do the same for all of these shapes, and you can see it's going to get a little bit messy here. So a good idea would be to just, once you've welded one, just move it out the way, like so. And what we'll do is we'll continue on then until we've welded all of those other parts. So I'd probably spend another 10 minutes here doing that. So what we're going to do is we're going to open up a file where everything's welded, and we'll go from there. Right then, so we can see here we've got everything laid out. Everything is now welded together. So there's a lot of parts, looks pretty much like a spine. So there's two things that we need to do now. First off is we need to think about, you know, how do we identify them? Because once we go and nest them, we don't know what part is what. So we're going to look at marking them by numbers, which will look at V-carving into each part, so that when we come to take them off the machine, we actually know what part goes where. Otherwise it will be a logistical nightmare if we didn't do that, seeing as there's like 80 odd parts here. And so what we're going to do is we're going to go in and we're just going to create a new layer here. So we'll add a new layer, and we're just going to call this one V-carve numbers. Okay, we'll just give that a blue colour like that, make that the active layer. And then it's simply a case of what I'm going to do is I'm actually going to try and put those numbers in the actual tab. That way they'll be super hidden. In fairness, they will be hidden anyway, because when it's up, you actually can't see that deep into it. So it doesn't really matter if it's kind of overhangs, but you want to be careful of the very end ones. You don't want those visible, otherwise it looks silly. So it's simply a case of just going in and just assigning each one of these a number, like so. And you'll just do that for all of the parts until you had all of those. So again, we're just going to jump ahead and then we'll look at the next step. So next up, we're going to look at filleting. So we want to make sure that we fillet every single internal corner. And the reason why we're doing that is because obviously we are using a round tool to cut in at those corners, okay? So a round tool cannot cut corners. So what we need to do is we need to apply dog bone fillets, and what that does is it allows us to sort of cut into that corner to ensure that the corner is cut, but you're going to be left with this sort of little dog bone look, which is why it's called a dog bone fillet. And really, at the size that this is, you're not really going to see it, so you'll just see like a small little sort of hole in the board, but at the scale that it is, it's not really that visible. And this will ensure that we cut through those corners to ensure that we can actually slot it in. And so the idea here is we're going to be slotting into every internal corner of all of these profile parts, and also the backboard as well. So every slot that we've got on the backboard, we need to ensure that all four corners has a fillet in it, okay? So we're going to look at using the fillet tool there. So we'll just actually pop that down. So we're going to go over into the fillet tool, which is this one over here. So the first thing you need to specify is your tool radius. So at this point, it's a good idea for you to know what tool you are using. Now I am using a 1/4 inch tool to cut this out. So my radius is going to be 1/8 of an inch. We're going to make sure we select the dog bone fillet, and then we're just going to go in and we're just going to click to apply those. Okay, so click, click, like so. And then we can click, click, click. And we're just going to keep on clicking until we've got all of those fillets covered. So at this point, it'd be good, again, to just jump to the next stage where all of the profile parts are filleted and all of the backboard is filleted. Now we've got all of our parts filleted. So this is the profiles. We've even done the backboard as well. So if you go to the backboard sheet, so if we just double click onto that, and then we'll just put that layer on, and then we'll just zoom in over here, and we can see all of those slots are also filleted as well. So everything's filleted, and I've also, in this file, I've also added in a little bit more geometry called the hanging holes, okay? So what I've done is I've drew a line, a centre line where the centre of the slot is, and this is for us to actually create the hanging hole. So the idea is it's actually going to be tucked away behind a profile piece. So a hanging slot will essentially sit behind this portion, so you'll never see it. And again, it's not really a big deal because at the size that it is, you probably wouldn't see it anyway because of the sheer scale of it. But if you were working on a small part, for example, like the lips that we've got here, you'd probably want to look at hiding them behind the profile pieces, just so that they're a bit more discreet, just looks nicer. So Todd actually gave me a good idea of creating what is essentially like a reverse T-slot. And so the idea is that we will cut in a rectangle, okay? So we'll have a rectangle that's going to be cut partially through at the depth of the screw. And then we're going to have a portion that's actually going to be cut all the way through. So it's going to look something like this, okay? So we'll have that. And then our screw will go in there, and basically the screw will sort of latch on to the top portion, and then that will, and then it will give us something to sort of latch on to, hang on to for when we slot it on. So the idea is that we're actually going to, again, because of the sheer scale of this, it's going to be easier for me to put all of the slots in the board on the floor or on a table. And then once we do that, we can then transfer that to the wall, and hopefully we can just sort of slot it on to those slots that we've got onto the screws that are already in the wall. So that's why we've got those there. Okay, so we're just going to do our final checks now. Now, one thing that does concern me is this slot over here. I feel that it's way too close to our board. It's a little bit, it's going to be very delicate if we actually cut this, and it will give us the potential to snap that board. So I'm just going to be bold here, and we're just going to delete it. And then what I'm going to do now is I'm actually just going to tweak the shape of the backboard as well. So what we'll do is we'll just put in another point here. So I don't want to change it massively, but I just want to sort of just give it a bit more of a rounded shape. We'll just nudge that, let's delete that point there. Okay, and then we'll just nudge that up like so, and we'll just tweak that. Okay, so it looks something like that. So creating a bit more of a organic shape there. We've lost that last slot, so what we need to do is ensure that we lose the slot on the profiles. So go to our profiles sheet, double click on that. Let's just switch off the backboard so we didn't see that there. And then what we're going to do is we're just going to go over here, and we're just going to delete that one so we don't need that anymore. So at this stage, we're actually ready to fillet all of those parts. So I'm just going to open up a file where we've got the perfect backboard. Okay, so I just did a little bit of tweaking there, but I've got my final design in a file. So we'll go ahead and open that up. Okay, so here is the finished backboard. So we've got some nice curvature there. Right then, so we're pretty much now at a stage where we are ready to nest our parts ready for machining. So what we're going to do is we're going to look at creating a brand new sheet. Okay, so we're going to add a new sheet, and we're going to rename that. I'm going to call this one Nested Parts. Okay, and the reason for me just creating a new sheet, again, it's just to sort of keep everything safe. So I've got safe sheets with vectors on. I've got layers that are safe, and they're all associated to their different sheets. So we're going to just jump into the 2D view. So you can see we've got our nested parts. Okay, now I'm going to jump to our backboard, and I'm just going to take everything here like so, and we're just going to say copy to sheet, and we're going to go to nested parts like so. Let's go into nested parts, and I'm just going to take that and just move that down for now. Then we're going to go to our profiles. Okay, let's just switch off the backboard and slots layer. And then what we're going to do is we're just going to, we also just undraw the bitmap. We don't need to see that. And then we're just going to select all of those parts, and we're going to right click and say copy to sheet, nested parts. Okay, so then we're just going to move on to our nested parts sheet. Let's get our layer up like so. Okay, so just to help us, let's just undraw the visibility of all of those other sheets. We only need to see this sheet that we're concerned with right now. So we've got all of our profile parts, we've got our backboard, and so now we're ready to nest. So we can take everything here and then we can go into our nesting tool. Okay, so nesting allows us to take our parts, put in some parameters, you know, assign tool diameters, clearance, border gaps, how you want to rotate your parts. And basically what it does is it enables you to create a layout that gives you sort of maximum efficiency of your material usage, which is why we're doing that, to ensure that we really maximize the space that we can work with. So we're going to specify our tool diameter, which is going to be 1/4 inch. We're going to have a clearance, okay, so that's the clearance between where the tool cuts out one part and the next part. Okay, and I'm going to go with 0.25 here as well. Then we're going to have a border gap of 1 inch. So there's going to be at least a 1 inch border around our sheet, and that's just going to help for when I screw my material down. Even though I'm going to be taping this down using double-sided carpet tape, I will still screw in the corners just for that extra security and ensure that, you know, we've got that flatness on our board. And so by having that 1 inch border gap, I just know that it's not going to, none of my parts are actually going to go into where a screw location could be. So we have the options here for part nesting options. Okay, so here I'm going to set my settings so that we can rotate our parts to find the best fit with a rotation step angle of 1 degree. So we can have our parts rotated in increments of 1 degree to ensure we get the best fit. Now this is okay when we're working with this sort of design and sort of birch plywood, but if you were concerned about the grain direction, this is where you probably want to, you know, you might not want to use 1 degree, but in this case I don't really care because we're not really seeing the side part of it. The main part we're going to see is sort of like the front on, which is the actual cutout parts, and we will only see the sides. And again, I'm not too fussed. Birch plywood usually has a nice face and it doesn't really matter about the grain direction there. And then we're going to remove the original parts, and so what it will do is it will just basically nest everything as is, and it won't like retain the original parts should I want them. I don't need them because I've got them on other sheets. Okay, number of copies, we're just going to go with 1. We're going to go ahead and press apply to assign that, and then we're going to go ahead and preview that, and then the software will just work its magic and it's going to figure out the best settings and positions for all of those parts across various sheets. Okay, so you can see it's just analysing that, and then what it will do is it will just spit out any extra sheets that I'll need, probably around 3, maybe 4 pieces that we'll be using here, and we can see what that looks like. Okay, so you can see we've got 3 sheets. We actually have a spillage here of 4, which is fine. So we'll okay that. I'm happy with that, so make sure you do press OK, otherwise it won't apply those settings. Right, and so we do have all of our parts nested out. Now before we go ahead and think about our toolpaths, as this is a slot together part, I highly recommend that we actually take an hour, half an hour to think about test pieces. Okay, so we're going to look at taking advantage of this extra sheet that we've got, and we're going to look at applying some tests. So what sort of tests are we talking about? So we're talking about tests in order for us to figure out the best allowance for our slots. Now when you are working with a slot together project, the idea is that you're going to be slotting one part into another, and we are using the material thickness of our tabs for our slots. And so if we don't overcut this, it's going to be extremely hard for us to actually put those slots into those profiles into those slot holes. Now we want to make sure it's tight, but we don't want to make sure it's too tight that we're really struggling. So we need to check some of those parameters. We also need to think about the larger areas of our board where we may have the 3 tab panels. Because we're only working with tabs that are, 0.36 wide, will they hold with a very, very large piece? So I want to kind of check the stability of that. And then also the way that our board is lined up, you can see how close these slots are. Obviously we know that the way we designed it. For every slot we have a space of a material thickness. Then we've got another slot. Would that hold enough because of how close they are? Would it implement some kind of, issue with its strength? And these are the things that I want to test. So what we're going to do is we're going to just open up a file that I've made where we've got some of the test elements, and we'll just quickly have a look at those. Okay then, so I've done a little bit of a rejig on our file. So we've got this test area. What I've done is I've put the widest profiles as part of our test area. As I mentioned earlier, I wanted to check that they're stable when they're so close together. And then obviously we've got our first test that we've got here where we're going to test different pocket allowances for these slots. And so where I've took these 5 panels, I've actually rejigged the rest of our sheets so you can see what they would look like over here. Okay then, so what we're going to do is we're going to look at creating our test pieces. So here we're going to go and run some pocket tests to begin with. So we're going to switch over to our Toolpath tab. So I've actually already just put those in for now, so I'm just going to double click so we can take a look at what's in that toolpath. So here we're going to start by creating our pocket for our slots. We're going to be cutting it all the way through. We're actually going to use a compression bit here. Okay, so with a compression bit, what we want to do is we want to make sure that the upward portion of that tool is going to be our first pass step, so that we don't have any splintering, because we want that upcut portion to be sat underneath the surface layer of our part. Okay, so in here we're actually going to go to edit passes, and we're just going to put in a value here, which is 2756. Okay, so put that in there, apply. So first pass depth is going to be quite deep. So that's going to eliminate that upward portion. And obviously you can get this value from either measuring the upward portion of your tool, or if the tool manufacturer provides that information, you could use that. Okay, so I'm just going to OK that. Just going to do that in an offset strategy, and we're going to set our pocket allowance first to be negative 0.005, and then we'll go ahead and press calculate. Okay, it's going to warn us that we're going to cut all the way through. That's fine, we want to make sure that we cut all the way through, so we're just going to go ahead and preview that. Okay, so that's our first one. Just switch on our vectors. Okay, next up we've got pretty much a duplicate of this test, except this time we're going in at negative 0.06. And so again, let's just take a look at that. We'll preview that. And then we've got our third test, which is going to be at negative 0.07. So we're overcutting wider and wider with each one of these tests. So we'll just go ahead and calculate that, and we'll go ahead and OK that, and then preview that. Right then, so that's going to be our first test, and then from there, once we figure out what the perfect sweet spot is, which in our case it actually turned out to be negative 0.007, I then applied that same toolpath. I just copied the toolpath, then applied it to this set here. So what we've got here is an actual sort of section that I've copied from the original backboard. So this is exactly as it is to that backboard. And then we've got the 5 adjoining pieces that needs to go into that as part of our test. Okay, so here what we're going to do is we'll just go ahead and calculate that, so we know that's going to be okay, and we can preview that. And then we'll put our vectors on. And then the idea now is for us to start to create the other toolpaths for the other parts. So we're going to close out at this point and we're going to go into the VCarve toolpath. Okay, so here we're going to look at just marking all of those numbers. And the way we're going to do this is we're actually going to use the automatic vector selection tool in order for us to get those vectors for us, so we don't have to manually click in. And because we've organised all of our vectors into layers, it's going to be super helpful for us to actually pick those up. So we're going to use a 60-degree half-inch V-bit. We're going to use this selector tool here. Okay, and so here we're going to go closed vectors, all closed vectors, and we want to make sure that we're selecting all the VCarve numbers. And you can see now I've done that, it's actually highlighted them. We'll associate that with the toolpath so that when we come to recalculate, it's just going to be associated with that. So we'll go ahead and calculate that, and then we can preview that. So we can see our numbers are all marked there, which is perfect. Put our numbers back on. Okay, so next up we're going to do our profile toolpath. So we're going to go into the profile toolpath. Again, same situation, we're actually going to get the software to pull out those vectors for us. So we're going to cut all the way through, again using that same tool. And make sure we edit our passes. So our first pass depth is 2756 here. Press apply, and then we'll go ahead and press OK. We're going to machine outside of those vectors. We're not going to add tabs to this, and the reason for that is because I don't want to be detabbing and clearing away any marks or visibility that there ever was a tab there. I'm confident in my double-sided carpet tape that it will hold everything down, so I'm just going to go ahead without the tabs. But of course, if you're going to do something like this yourself, then please ensure that everything is safe and appropriate for your particular setup. Okay, so we're also going to add ramps. Okay, so this is going to help protect the wear and tear of the tool rather than us plunging straight into our material. We're actually going to look at just kind of ramping in, so we ease the pressure off. We're going in like a diagonal Z movement there. We're going to add leads so that we're going to be leading into the cut, so we're not cutting directly at the surface of our part. It's going to cut some part away, whatever we assign here, and then it will lead into the cut the part out, and then it will lead out. So we want to make sure that we also do a lead out on there. So we've got a lead out selected here, and we're going to do that in a circular radius here. If we go back to our ramps, we're also going to ramp in on the lead, so we're doing a combo there. Going to our selector tool, we're going to press all the closed vectors, and we're going to use the profiles for that. That's it, profiles with tabs. Okay, so these are the parts that it's going to cut out. So we'll associate that, close out, and then we'll go ahead and calculate that. It's going to warn us we're going to cut all the way through. That's fine. We'll preview that, and then we can see that there. Okay, so another thing that I noticed, that it didn't actually pull out the profile for the test. So what we could do is we could look at assigning that vector to that layer. So what we'll do is we'll take that, we'll say move to layer, and we'll move that to our profiles with tabs. I'm also going to move this one, so move to layer, profiles with tabs. Okay, and then over here we just need to assign our sort of reverse keyhole part. So what we're going to do is we're going to take this vector here, so this is the longer of the two. We're going to run a pocket toolpath, and then what we're going to do is we're going to cut in partially here, so 0.15. Okay, now I'm not too fussed about the upward portion of this because this is going to be hidden away, so it doesn't really matter in this case. So we're going to call this one pocket hanging slot. Okay, and then we'll just go ahead and we'll calculate that like so, and we'll preview that, and then we'll close out, and then we're going to switch on our vectors. I'm going to take that smaller one, and then again we'll go into the pocket toolpath this time. We're going to go 0.37 in there, and then what we're going to do is we're going to again call that pocket hanging slot 2, and we'll calculate that. We'll go ahead and press OK, and we'll preview that. Okay, right then, so if we just go back to our profile and we'll just recalculate that, it should pull out the other vectors that we've associated to that layer. So you'll see that there. Okay, so these are all of our test parts. So we'll take a look at how the testing went. Okay then, so all of the testing worked out perfectly. So in terms of the pockets, the sweet spot was 0.007. So we're going to go with that for all of our main slots. I was happy with the distance between each of those slots as well. It seemed like everything was pretty stable, so that's all good. So now that we've got all of our toolpaths in our test, we're actually going to look at just copying those toolpaths over to the different sheets, which we'll recalculate with those toolpaths moved over to assign to the various vectors, which is why with a lot of those we actually assign them automatically through their layers. Right then, so if we just go into our 2D view, we can take a look at what we've got. So in terms of the slots, we only need to move the slots and the hanging holes to the nested parts 1, and then everything else can go to across parts 1, 2 and 3. Okay, so vcarve, let's just right click and we're just going to say copy to sheet. We're going to go nested parts 1 and we're going to go copy to sheet, nested parts 2 and copy to sheet and nested parts 3. Then we're going to go to a profile. I'm going to go copy to sheet number 1. Copy to sheet number 2, copy to sheet number 3. Right then, the hanging slot, so copy to sheet, I know that's only on 1, and then we'll go hanging slots 2, copy to sheet, again number 1, and then that pocket at -0.007, copy to sheet, and then again nested 1. Okay, so now we just need to go through to sheets 1, 2 and 3 and just recalculate those toolpaths. So you can see we've got those toolpaths copied over. You can see that there's nothing assigned to them at the moment. That's why they're 1 in italics and 2, they have a red exclamation mark on. It's a warning for us to say like, hey, you need to do something with this. So we're going to double click here onto our pocket toolpath. So this is our slots at -0.007. We're going to go to the selector and we're actually going to select our backboard and slots. So you can see they're all selected there. Okay, and we'll associate that. Then we'll just go ahead and press calculate. Okay, it's going to warn us we're going to cut through. We are aware of that. We know that that's going to happen. And you can see that now that we've done that, we no longer have that exclamation mark. It's no longer in italics as well. So next up, we're going to apply the vcarve. Okay, so you can see because we already had that associated, it's already pulled out all of those vectors, which is really handy. So all I need to do is go ahead and press calculate, and then it will just assign that. Same for the profile. When we go in there, you can see if we just switch on our vectors, it's assigned everything that's on that layer, like so. And then what we can do is go ahead and press calculate. It's going to warn us we're going to cut through, which is fine. And then we could go ahead and preview that, and we can see what that looks like. And then we've got our hanging slot. So here we've got our hanging slot, our first pocket. Okay, so that's where we're going to be cutting partially through there. So what I want to do is I want to just take this one here, and you can see I've got them all selected. Okay, so we'll go ahead and press calculate, and then we can preview that. So that looks like that. And then finally on the last one, we're going to take those vectors, the other vectors, which is this one here. And again, I've grouped them, and we're going to cut all the way through. We'll calculate that, and then we'll go ahead and preview that. And then that's our hanging holes in situ there. We've got all of our parts, and then what I'd do then is I'd just go ahead in the same process for the other sheets to recalculate those. And so at this stage it's simply a case now of saving out those toolpaths, cutting them on the machine, and then going through the big huge assembly. Okay, so there it is. It looks awesome. I love the way that it looks. It's probably one of my favourite projects that I've worked on. And you can have a go at creating this yourself if you wanted to. So all the files that we demonstrated in this session will be available as part of the purchase bundle that you can get from the store. So thank you for watching, happy making, and we'll see you in the next session.